So what I'm going to do is I'm going to go ahead and create a repo from scratch that will cover everything that we'll go through in this tutorial. And so I'm going to start off inside of GitHub here, and I'm going to create a new repo. And a couple things I'll mention about this is that I'm going to use a feature called GitHub Code Spaces, which is widely available now, and anybody can sign up for it. And I've found it to be one of the most useful tools available. And we'll use a little bit of Colab notebooks as well, which is also a widely available, useful tool. And these are all things that you can run without using GitHub Codespaces or Colab, right? You can run Jupyter Notebook standalone, and you also can do, run your own environment. So there's nothing that's necessarily proprietary about what we're doing, but we'll just call this Mastering Functions 2022, and we'll create a repo that says this is a repo for mastering Python functions. All right. And always a good idea to add a README. Always a good idea to add your gitignore so that you don't check in files you don't intend to. And then if you choose, put a license. Okay, so I'm going to go ahead and create this repo. And as I mentioned, one of the things that I like to develop in is GitHub Codespaces. And you'll see it's available if you have access to it or you sign up for it by going to this green button right here. I'm going to go ahead and select the green button, and I'm going to do something a little bit unique. Is I'm going to select here, and I'm going to select configure and create code space, which is an advanced option. And if I go ahead and I select that, I can go ahead and configure and create it. And I'm going to create a 16 core experience. So you can see that's one of the nice things about the future world that we're headed into is that many times the cloud-based environment, like in this case, GitHub Codespaces, is more powerful than most machines, right? Not many people have a 16 core laptop. This is a very powerful environment. So this is probably much more powerful than many people's laptops. We go through here and we say create code space. And usually it spawns a code space in not too long, probably I would say about just a few seconds actually, and let it it has to go through at the beginning and wake things up a little bit and throw these getting starteds around. The first thing I typically do is change the color theme because I like the dark color theme. I find it easier to read things. There we go. And if I go ahead and refresh this thing now, stay control. We're now in a great place to start building out some code. So the first thing that I would do in a repo like this is always create a Python virtual environment, because of the fact that it solves a lot of packaging problems. Because if I know in the future I'm going to build stuff, and so in this environment, I would just type in the word virtual env, and then I could do tilde.venv. This is a convention I like to use that will allow me to create it into a home directory and a hidden directory so that it's away from me and I don't accidentally check it into a repo. So once I do that, what I like to do is put it into my bash configuration file, which is in bash rc. So I'll say vim and I'll say .bash rc, and I'll go to the end of the line and just put this source here. So source the virtual environment, and we'll just do that. We'll just say source, and we'll say bin activate. There we go. Just like that. And once I've done that, all I need to do is I can just open up a new shell, and look, you see that I've been able to source it. I can just get rid of that old shell. And now I'm pretty much ready to go to start playing around a little bit more with Python. A few things I'll start off with Python are that it's important to know about the different interpreters. So to start with, we've got Python right here. And in this particular scenario here, when I type in the shell, it gives me the interactive prompt, and I can do things like say import OS and say os.lister, and it will autocomplete, and I can basically run commands at will by just putting them into this interactive interpreter. So that is a useful way to test out little snippets of code. What I found though is that if I'm going to play with interactive Python, that the IPython interactive terminal is actually a lot more convenient. So now we've reached the point where it's probably a good idea to install IPython. And in order to install IPython, we should probably build a project scaffold for this repo. So for me, and I'll put this into the README, we'll say, project scaffold, what are the components? It would be a makefile. It would be a requirements.txt, and it would be in any other source code files, and that's it. It's a very simple process. And so I'll go ahead and do that. I'll say touch makefile. So the touch command will just create an empty file. I'll say touch requirements.txt. I'll say as well, that's it actually. I don't have source code files right now, so I don't need to do that yet. And what I'll do is inside of the requirements here, we'll put in the package that I want to install. I want to install IPython. And the only other thing that we need to do is we need to populate this makefile here, because the makefile itself will be what I use in order to install software. And so I think I have one laying around here. I can go back to the functions bike writer and just copy one of these, and they're boilerplate code that is just useful in projects. Some of this other stuff we can come back to, but basically this is something I find to be useful in projects, is to put this install block. And what it does is it uses the Python installer, and it upgrades the Python package tool pip, because it always needs to be upgraded. And then it goes through and it looks inside of this requirements file. So there we go. We got this thing cooking here. We can close that. And I can just say make install. All right, so we got the IPython installed. Now we can test it out. We just type in IPython, and on my end, this is a much better place to play around with code, because it's just an easier environment. So if I again go to import OS, and I say os.lister, right, and we do the same thing, like show me what's in my directory. It even allows me to capture the variables easily. I can run type. I see what the variable is. I can see it's a list. I can also slice the list. It's just a very, very handy environment to play around with, especially with functions, right? Because it handles the interactive nature of things a lot better. So definitely, I would say when you're playing around with the interpreter, right, is to prefer IPython. So we'll say, Python interpreter here, interpreter. we'll say, we got the regular Python shell, and we have IPython mini prefer, right? So that's really our place for executing interactive statements, but we can also write a statement by putting it into a script. And so now we are going to get to the source files. And so if we go to a script here, and we say scripts, let's go ahead and do that. We'll say touch hello. And inside of here, I can go ahead and say something about, I don't know, let's do print hello world, right? That's kind of the classic thing to say. And notice that the GitHub Codespaces environment is very good. It has great syntax highlighting, lots of helpful things that help us write good code. So now that I've got that, in order to make this executable, you would do chmod plus x, hello, like that. And then you would just do /hello. Oh, we forgot something. We forgot to put Python up here. So we'll say user bin Python. There we go. Why am I doing my, I got to look at my Python shebang line and make sure that, there we go. I just mixed up the order. There you go. So that looks good, right? User bin, bad interpreter, Python. There you go. Hello world. It looks good. So we got a shebang line here. User bin, env, Python, print hello world. And the steps here would be, like this. And so we can put this into the README as well. So we'll just say this, make a hello, chmod it, and then run it. So pretty straightforward actually to create a script here, and we can put this into code blocks here so that other people in the future can read it. Now, what other ways can we run Python? The other one that, as I mentioned before, that's pretty handy actually, is Colab, especially for statements. I would say functions less handy, but statements, I would say Colab Notebook. So let's go ahead and fire that up and integrate it with what we've got going as well. So I'm going to open up another section here. We'll call this notebooks, Colab and Jupyter notebooks. There we go. So I'm going to open up another shell here. I'm going to go to Colab, and here we go. I'm going to say, no, I don't want that. I want this. So Colab Notebook is a very unique tool. You can see here that it has examples, so you can go ahead and play around with the different things that Colab does, and it's actually a great proprietary tool from Google with some compatibility to Jupyter. You can also make directories full of Colab notebooks. I may have created, 1,000. I've created a lot. You can also integrate it directly with GitHub, or you can even upload things. So what I can do is just create a new notebook to start with, and we can say, in our case, mastering functions, or actually let's just call this one statements 2022. So what's nice about this environment is that you can just start immediately, doing things. So you can say print hello world. we go. And it just goes through and it prints hello world. You also can create these blocks by adding a text cell. And this is really handy to organize your thoughts. So if I go through here and I say, hello world, right? I know now if I go to the section here, the table of contents, it'll create a subdirectory inside, just like that. And in addition to that, I can create additional blocks underneath that are nested. So if I did one more, say more hello world, like this, and we can say prints more hello world, just like that. And if we go through here, you can see I can collapse it, right? And it still shows the structure. So a really useful tool for, again, interactive statements in general. So let's do a little bit of interactive statements here and dive into some of the things that you can do. I would say probably the number one thing that people probably want to play around with interactive statements is strings. So let's dive a little bit into that. So we'll go into strings. And so Python strings are pretty useful because they allow you to format text. And so if we go in and we put in a statement here, statement is equal to, this is a sentence. This is a string. How do we know it's a string? Well, what we can do in Python is we can do this. We can say statement, type statement, and it will go back and it'll show us that it's a string. Now, also, if I hover over this in the Colab notebook, it even tells me. So I don't even have to do that anymore because it has this neat little feature that it shows me, oh, look, that's a string, right? And it even tells me exactly what's inside. To format a string, one of the most common things to do is to take variables and put those into some kind of a statement. And so let's say, for example, I had some fruits and I put them into, let's say a list. And we had an apple and we had a pear and we had a fig. And if I want to go ahead and put that into a statement, it's pretty straightforward. I would just type in print again, but this time I would use something called an F string. And an F string allows you to template out variables very simply. So if I wanted to make a statement that said, an amazing fruit salad uses the following fruit, something like that, right? That's kind of a logical statement. All I need to do is this, right? I would just need to put these curly brackets here, and inside of them, I would just need to slice that list. So it's a fruits 0, and then I would say fruits 1, and I would say fruits 2. And now if I return, an amazing fruit salad uses the following fruit, apple, pear, fig, right? So that's kind of the essence of the majority of the things you would do with strings. The other thing that comes up in Python statements would be, the variables, which are either a list or a dictionary, and we can cover that very, very quickly. And we just go through here and do that. So we'll say lists and dictionaries. And inside of these things, really the essence is a list is sequential. So if I say numbers, this is kind of a good example. 1, 2, 3, 4, 5. Or actually, let's do this. Let's make it logical. No, yeah, let's make it logical. Let's do 0, 1, 2, 3, 4, and then we'll call this number phrases. And then in a dictionary, the way you access it is key value pattern. And so you could say, basically number 0, number 1, number 2, and then number 3, and then number 4. Right, so what am I missing here? Equal sign. Kind of nice, it gives us really good debugging, and I need to put these into variable format because those weren't defined. So really another nice thing about writing statements in an environment like this is it helps me debug my code as I'm writing it in a very intuitive way. It's like, hey, you can't define a key without using the proper syntax. There we go. So we got the proper syntax. Now to access the list, and I can even put an annotation here, right, that says list dictionary, like that, right? So we even have it annotated. So the first thing is let's access the list, and we just say numbers 0. It returns 0 numbers, and if I want to do the very last one, I can do 4, and it will give me 4. And I can also do things like go from the right to left with a list, and I can say numbers -1, and that gives me 4, right? And with a dictionary, we would go through here and we would say number phrases dot keys, right? So you can actually just pull in just these, right? You can just say, oh, show me just the beginnings, or you can also do the values, right? So those are probably the two most common ways to deal with things, and then people, if they want to go further, probably the last, like, most bare essential thing you would do with statements would be to do some kind of a for loop. So let's do that as well. So let's bring this down. Let's bring this down, and we'll call this loops. So since we already have some variables up there, we can go ahead and use those, and we can say basically for num in number prints num. Right, that's going to be the easy way. What did I call it? Oh, numbers. Okay, so we can make it easier for number in numbers print number. So the magic is, this is the loop variable. It gets replaced every time. It gets replaced every time the loop goes through. So we go through here. Perfect. Now, and then you can do the same thing for the dictionary. You can say for key value in number phrases dot values, and I got to replace this number phrases like that. So values will get both the key and the value. You can just say prints f string key is key and value is value. Perfect. What did I do wrong? So for key value cannot pack number phrases. Let's see what I did wrong here. If I just print this out, does that work? So that's always a good way to debug things is first, is it that I didn't use, it needs to be items. There we go. Yeah, when you iterate, if you want to just print it out, the values, you would do what I did. But if you want to get both the key and the value, you do items. So there we go. We got all of Python statements in just a few minutes. So now that we've explored that, we can even look at the table of contents, look, all these really neat things here. So